Hi, I'm Paul Battaglia, and this is section 4.4, trigonometric functions of any angle. In section 4.4, the focus will be on trying to move students away slightly from some of the traditional right triangle trigonometry definitions we had. So I have Gabe and Brittany along with me, and Brittany, you're going to start us off. Tell us a little bit about how you move your students out of that SOHCAHTOA realm.
Yeah, so I tell my students we're going to shift from just the definitions using SOHCAHTOA, and now we're going to use X, Y, and R.
Okay.
Mm-hmm. And
do you find that a little bit more logical for them, or?
I think it's a little bit more difficult for them.
Okay.
Only because they're so used to
Right.
SOHCAHTOA
Right.
from seeing it in geometry and everything. So.
And one of the ways, I guess, that I help bridge that gap from SOHCAHTOA into this trigonometric functions of any angle is you can always tie it back to these ideas that we found in right triangle trigonometry.
Oh, yeah.
So maybe if they're looking at a point in a second quadrant, maybe have them draw the triangle, but now instead of thinking about like a negative side length or something strange like that, just think about, well, you're moving in the negative direction along the x-axis, so your x value should be negative, but your y value will still be positive.
Okay, all right. Is there a way that your students start to maybe develop number sense there and try and get themselves to the point where, as they move around the quadrants, they're understanding which trig functions are positive, which are negative?
Yeah. So, like even just starting in the first quadrant, we see that all the trig functions are positive. As we move to the second quadrant, well, sine's positive, and so is its reciprocal, cosecant.
Okay.
And just moving around the unit circle, how I have them, moving around the four quadrants, how I have them memorize this is just all students take calculus, where all the trig functions are positive in the first quadrant, sine's positive in the second quadrant, but then so is its reciprocal.
Okay, so they go hand in hand, right?
Third quadrant, tangent's positive, so is cotangent, and then in the fourth quadrant, for calculus, cosine's positive, and so is secant.
You see, and that's good because it's almost like an acronym of sorts, So
exactly.
ASTC, and then they kind of associate it with these words, and then obviously the trig functions, which is good. I think when we're talking about number sense, we then naturally gravitate towards the idea of a reference angle. We can't, we go back to your triangle idea, Gabe, we cannot draw a triangle with 210 degrees in it. So if we were to draw a 210 degree angle, how do we do that? And I know that we want to get them into the idea of, well, that's 30 degrees past the horizontal. And so we can form a triangle, but what we have to point out to students is that when we draw the triangle, it has to go back to the horizontal, the x-axis, right?
Yeah, that's something that students may confuse, and you really want to keep guiding them towards drawing their triangles using the horizontal x-axis.
Right. I think these things are really important points that you want to make sure your students have really mastered by the time they're done with section 4.4. So I hope these tips have been helpful for you and you find much success in section 4.4.